At first, nothing seems extraordinary. A small dark curve appears at the edge of the sun, daylight remains, and the world continues as usual. Then the air cools, shadows sharpen, the sky turns strange, and in one breathtaking instant, the sun disappears, revealing a silver corona around a perfect black circle, while planets shine in the middle of day. Totality lasts only a few minutes, yet for many who witness it, those minutes become some of the most unforgettable of an entire lifetime. Thank you for spending part of the day here. A quiet like, a subscription, or a share helps this channel continue creating calm journeys through science and the universe. What time is it where this is being watched, and from which place in the world? Please leave the answer in the comments. Now, let the moon's shadow approach and step into the remarkable science, beauty, and meaning of a total solar eclipse. A total solar eclipse begins with a geometry so simple that it can be drawn with 3 circles, yet so exact that generations may pass without seeing its full effect from the same place. The sun shines at the center of the solar system, the moon moves around Earth, and Earth continues along its broad path through space. Most of the time, these motions carry the 3 bodies past one another without perfect alignment. The moon may pass above the sun in the sky, or below it, because its orbit is tilted slightly in relation to Earth's orbit around the sun. Only when the timing is precise does the moon move directly between Earth and the sun, casting its shadow across the planet. Even then, the deepest part of that shadow touches only a narrow corridor. Within that corridor, daylight does not merely dim. For a few minutes, the visible surface of the sun disappears. This is totality, one of the rare natural events in which familiar knowledge does little to soften the shock of what occurs. The mechanism is well understood. Maps can show where the shadow will travel, how wide the path will be, and how long the darkness will last. Yet prediction does not make the experience ordinary. The event remains a meeting between exact astronomy and the human senses, between a motion unfolding for billions of years and a brief life that may encounter it only once. The rarity is not mainly caused by eclipses being uncommon somewhere on Earth. Total solar eclipses occur often enough for astronomers to anticipate them with confidence. The difficulty lies in location. The moon's central shadow is small compared with the size of the planet. It sweeps across oceans, mountains, cities, and empty regions, tracing a temporary path that may be only about 100 miles wide. Outside that path, the eclipse is partial. The moon covers part of the sun, sometimes nearly all of it, but a narrow arc of exposed sunlight remains powerful enough to keep the sky bright. Inside the path, the final sliver vanishes, and the world changes category. For any single place, the wait between total solar eclipses is usually measured in centuries. A town may see one, then pass through generations of local history before the moon's central shadow returns. The same field may darken under one eclipse and not do so again until every witness is gone. The same coastline may receive the shadow after generations have lived beside it. The eclipse is both predictable and deeply personal. It belongs to astronomy, but also to chance, geography, travel, weather, and the limited span of a human life. The scale of the alignment seems almost impossible because the sun and moon are so different. The sun is a star, vast enough to contain Earth many times over, while the moon is a small rocky world. Yet from Earth, they appear nearly the same size in the sky. The sun is far larger, but far more distant. The moon is much smaller, but close. Their apparent sizes nearly match, allowing the moon to cover the brilliant solar surface while leaving the faint outer atmosphere visible around it. This balance is not exact and does not remain fixed. Neither orbit is a perfect circle. At some eclipses, the moon appears slightly too small to cover the sun, leaving a bright ring. At others, it appears large enough for totality. The difference may be slight, but the result is complete. There is no intention in this arrangement, no cosmic design required by the science. Yet the visual effect carries the precision of a lock turning at the correct moment. The moon's dark disk fits across the sun. The last fragments of direct light disappear, and the hidden corona begins to show. That outer atmosphere is always present, extending far beyond the visible edge of the sun. But ordinary daylight overwhelms it. Only when the moon blocks the brighter surface does the corona become visible to the unaided eye. The eclipse, therefore, does not simply remove something from the sky. It reveals something normally concealed by brightness itself. Long before totality, the event begins quietly. The moon first touches the edge of the sun as a small dark notch. Through proper eclipse viewers, the missing portion grows until the sun becomes a thin crescent. On the ground, the day may still feel normal. The sky remains blue. Clouds, buildings, trees, and distant hills keep their usual forms. Without safe filters, the change in the sun cannot be watched directly, and without attention, the landscape may seem almost untouched. This early stage can create the impression that a total eclipse is simply a partial eclipse carried further, an interesting reduction of sunlight rather than a complete transformation. That impression survives until the final minutes gather. The air cools because the ground receives less solar energy. The quality of light changes in a way that is difficult to compare with evening or storm. Shadows sharpen, colours flatten. The landscape appears both clear and strangely drained, as though daylight has become thin without yet becoming dark. Animals may respond to the falling light, birds may quiet, insects may begin evening behaviour, and the ordinary rhythm of day may hesitate. These changes vary by location, but they signal that the sky is moving toward a state that does not belong to a normal afternoon. The shadow races across Earth far faster than any person can travel on the ground. Its speed changes with the geometry, but to those waiting in the path, it can seem less like an object than an advancing absence. In open country, distant darkness may appear along the horizon. Over the sea, ships may turn on lights. Across a city, street lamps may awaken while the sun is still partly visible. The world does not enter night in the usual way. Sunset lowers the sun toward one horizon and draws darkness gradually across the sky. During a total eclipse, darkness descends while the sun remains overhead, and the horizon may glow in every direction beyond the edge of the moon's shadow. This is where rarity becomes more than a statistic. A person may understand that the event occurs only occasionally at one location, but the meaning becomes sharper when the final seconds approach. There is no way to extend them. The celestial motions continue at their measured pace. The moon does not wait for clouds to clear, for a camera to be adjusted, or for attention to settle. Years of anticipation narrow into a moment lasting only minutes. A small mistake in location can place an observer outside the path. A passing cloud can hide the sky. A delay in travel can erase the opportunity. The event is certain in the mechanics of the solar system, yet fragile in the experience of any individual. That fragility explains why people cross borders, oceans, and continents to stand beneath the moving shadow. They do not travel because the science is unknown. They travel because the science describes an event that cannot be fully replaced by description. Photographs preserve the black disk and the luminous corona. Measurements reveal the structure of the solar atmosphere. Videos record the sudden darkness and the sound of crowds. Each record separates the event into parts. Totality is not only an image in the sky, it is a change in temperature, light, horizon, sound, scale, and perception all arriving together. The alignment also places a human life inside a much older pattern. Solar eclipses occur because the moon has orbited Earth through deep time, slowly changing its distance while Earth turns beneath it. The same kind of shadow crosses ancient seas before human beings exist. It passes over forests that later vanish, over mountains that later erode, and over landscapes that leave no living witness. Civilizations eventually learn to predict the cycle. Modern astronomy refines that prediction until future paths can be mapped with extraordinary accuracy. Still, when totality arrives, the response is often immediate and wordless. Knowledge remains, but it is joined by awe. The first reason everyone should see a total solar eclipse is therefore not that it is unexplained, but that it makes explanation feel larger. It reveals how a simple alignment can alter an entire world of experience. It shows how distance and size can balance across space, how a shadow can travel across a planet, and how an event lasting only a few minutes can become one of the clearest memories of a lifetime. The sun, moon, and Earth continue their motions without regard for any witness. Yet when their paths briefly meet, the result feels intimate. A cosmic arrangement becomes a personal moment, and the narrow shadow crossing Earth becomes a reminder that rarity is not measured only by how often something happens, but by how few chances a single life may have to stand beneath it. A partial solar eclipse can be beautiful, precise, and scientifically rich, yet it remains separated from totality by more than degree. The difference is not simply that one covers less of the sun and the other covers more. The difference is that the final uncovered fraction of the solar surface, however narrow it becomes, continues to dominate the entire scene. Even a thin arc of direct sunlight is powerful enough to keep the sky bright, to hide the solar corona, and to preserve the basic character of day. This is why a partial eclipse may feel like an unusual event happening within the normal world, while a total eclipse makes the normal world itself seem to disappear. During the early stages, the moon moves gradually across the face of the sun. Through approved eclipse filters, the dark lunar edge looks clean and absolute. It advances without visible haste, carving a deeper curve into the solar disk. The sight is elegant because it reveals orbital motion directly. The moon is not merely somewhere in the sky, its movement becomes visible against the sun, and the change can be followed from minute to minute. Yet on the ground, ordinary daylight remains surprisingly strong. Human vision adjusts easily. The eyes respond to reduced light by becoming more sensitive, and the brain continues to interpret the landscape as daytime. Even when much of the sun is covered, streets, fields, buildings, and faces may still appear familiar. The change is real, but it is masked by adaptation. This creates one of the central misunderstandings about eclipses. A person who has seen a deep partial eclipse may believe that totality is simply a darker version of the same experience. The assumption seems reasonable because both events begin with the same geometry. In both cases, the moon passes in front of the sun. In both cases, the solar disk becomes a crescent. In both cases, the temperature may fall and shadows may change. Yet the final step does not extend the earlier stages in a smooth way. It crosses a threshold. As long as any part of the sun's bright surface remains visible, the direct photosphere continues to flood the atmosphere with light. The photosphere is the layer that normally appears as the sun's visible face. It is so bright that the much fainter corona cannot be seen beside it. The scattered sunlight in Earth's atmosphere also keeps the sky blue. When the final sliver disappears, both conditions change at once. The source of direct glare is removed, and the hidden structures around the sun emerge. This is not an increase in spectacle by a small amount. It is a transition from one visual world to another. The distinction is similar to the difference between standing outside a theatre before the lights go down and sitting inside after the stage has gone dark. The room may dim gradually, but the final darkness changes where attention goes and what becomes visible. During a partial eclipse, attention remains divided between the familiar landscape and the altered sun. During totality, the entire environment becomes part of the event. The sky darkens, the horizon glows, planets appear, and the corona surrounds the black disk of the moon. The eclipse no longer sits inside the day. The day has become the eclipse. This threshold can be measured precisely. Observers near the edge of the path of totality may experience only a brief interval of full coverage, while those nearer the center may receive more time. A small difference in location can determine whether the last line of sunlight remains or vanishes. That narrow boundary separates a deep partial eclipse from totality. On one side, eclipse glasses must remain in place because the sun is still exposed. On the other, during the fully covered phase only, the hidden corona can be viewed directly. The physical distance between those two experiences may be only a few miles, yet the sensory distance is immense. This is why eclipse maps matter so much. They do not merely indicate where the view is better, they mark the border between two different natural phenomena. The partial phase still offers subtle wonders of its own. Beneath trees, small gaps between leaves act like pinhole projectors. Instead of ordinary patches of sunlight, the ground fills with tiny crescents, each one an image of the partly covered sun. The effect may appear on walls, sidewalks, clothing, and open hands. It reveals that sunlight arriving through each small opening carries the shape of the source. Shadows may also sharpen because the visible part of the sun becomes narrower. Under normal conditions, the solar disk is broad enough to soften shadow edges. As the disk contracts into a crescent, the light comes from a thinner direction, and outlines become unusually crisp along one axis. These changes are delicate and instructive. They show how the size and shape of the sun influence everyday light, even when that influence usually goes unnoticed. The cooling air also carries information. As less sunlight reaches the ground, surfaces begin to lose heat. A breeze may form as local temperature differences shift. The sensation can be sudden, especially under clear skies. Yet none of these signs fully announces what totality will become. They are signals from an approaching boundary, not smaller versions of the final state. The final minutes intensify the contrast. The remaining crescent becomes too thin to produce normal illumination, but still too bright to look at safely without protection. The light may take on a metallic or silvery quality. Colours lose warmth. Skin, stone, grass, and water appear slightly unreal, as though the spectrum of afternoon has been narrowed. The sky remains lighter than night, but it no longer resembles ordinary day. The nervous system recognizes that something is wrong with the expected relationship between the sun and the world. The sun is still above the horizon, yet the air cools and the landscape fades. Twilight seems to arrive from the wrong direction and at the wrong speed. The reaction is not based on ignorance of astronomy. It rises from the deeper patterns by which living creatures read light. For almost all of human history, a high sun means day. Totality briefly breaks that association. The partial phases prepare the setting, but they do not break it. Even at extreme coverage, the exposed photosphere remains strong enough to hold the world in daylight. This persistence explains why photographs can be misleading. A camera can adjust exposure until a partial eclipse looks dark and dramatic. It can show a narrow crescent hanging in a black sky, making the image seem close to totality. Human vision at the location experiences something different. The surrounding sky is often still blue, and the environment remains visible without artificial light. Conversely, photographs of totality may fail to show the full range of brightness in the corona, the colours near the horizon, and the detail perceived by adapted eyes. The camera can isolate the sun, but totality is not isolated. It surrounds the observer. The difference also has emotional consequences. A partial eclipse invites observation. Totality often produces silence, shouting, laughter, tears, or a sudden inability to speak. The response varies, but the intensity comes from the abruptness of the threshold. The final bead of sunlight disappears, and the ordinary sun is replaced by a black circle bordered with pale fire. The change happens faster than the gradual partial phase suggests. Long preparation leads to a transition lasting only moments. The mind has little time to adjust before the sky presents an arrangement that is both recognizable and impossible. The black disk is known to be the moon. The silver light is known to be the solar atmosphere. The planets are known to remain in their orbits. Still, the combined scene feels unlike any normal view from Earth. This is why descriptions based only on percentage conceal the essential truth. 90% coverage does not provide 90% of totality. Even nearly complete coverage remains partial, because the exposed sun continues to control the sky. Totality begins only at complete coverage, and the experience changes discontinuously at that instant. The last fraction matters more than all the fractions before it. It is the difference between seeing the sun diminished and seeing the sun transformed. A partial eclipse demonstrates celestial mechanics with clarity. It shows the moon's motion, the curved geometry of two distant bodies, and the changing character of sunlight. It deserves careful attention and safe observation, yet it cannot serve as a substitute for standing inside the moon's central shadow. The partial phase is an approach, a long narrowing of brightness, a sequence of clues. Totality is the revelation those clues cannot fully explain. The distinction becomes the first great lesson of the event in nature. Gradual change can lead to a sudden threshold, and two moments separated by only a sliver of light can belong to entirely different worlds. The shadow approaches long before darkness arrives, but at first it gives almost nothing away. The moon continues across the sun with steady motion, and the bright disk narrows into a crescent. The landscape remains visible. Roads, buildings, trees, and water still hold their ordinary forms, yet the light no longer behaves in an ordinary way. It weakens without becoming soft. It cools without becoming blue. It seems to lose fullness, as though part of the day has been quietly removed. This is the beginning of the approach, the phase when the eclipse stops being only an image through a filter and becomes an event in the surrounding world. The change is gradual enough to escape notice, then sudden enough to feel uncanny. Human vision adapts quickly to changing brightness, so the decline in sunlight is easy to underestimate. The eyes widen. The brain maintains a stable picture of the scene. A field can still appear bright even after much of the solar surface has been covered. Only comparison reveals what is happening. A white wall looks duller than it did earlier. Water reflects less glare. The sky has lost some of its depth. Colours remain, but they seem less warm and less complete. The eclipse advances through these small losses. Each one is subtle, but together they begin to separate the moment from any normal afternoon. The temperature often falls next. Sunlight heats the ground, and the ground warms the air above it. As the moon blocks more of the sun, this energy weakens. Pavement, sand, stone, and soil stop gaining heat and begin to cool. The air may feel unexpectedly fresh against the skin. Even under a clear sky, a light breeze can form as local air currents adjust. The effect does not resemble evening, because the sun is still high. It does not resemble a storm, because no cloud has covered the sky. The coolness arrives without the usual cause, and that absence makes it noticeable. The body recognizes a pattern it has known since birth, then discovers that the sky no longer follows it. Shadows also begin to change. Under normal sunlight, the sun is not a point but a broad disk, so the edges of shadows blur slightly. As the visible sun becomes a thin crescent, the light comes from a narrower shape. Shadows sharpen in one direction and soften in another. Leaves, fingers, railings, and branches produce outlines that look strangely exact. Beneath trees, the gaps between leaves act as tiny projectors, covering the ground with repeated crescents. Thousands of small solar images may appear on pavement or grass, each one showing the same hidden geometry overhead. The effect is delicate, almost playful, but it also shows that the eclipse has entered every patch of light. The entire landscape has become an instrument recording the shape of the sun. Animals sometimes respond before people do. Birds may quiet or gather as if evening is near. Insects that become active at dusk may begin to call. Domestic animals may show confusion or simply follow familiar routines linked to fading light. These responses differ from place to place and from species to species, but they reveal how deeply life depends on the daily rhythm of the sun. A total eclipse interrupts that rhythm for only a short time, yet the interruption is clear enough to reach nervous systems that know nothing of astronomy. The world of instinct begins to prepare for night, while the world of reason knows that midday remains. The two systems briefly disagree. As totality draws closer, the light takes on a quality that photographs rarely capture. It can appear metallic, silvery, or slightly grey, as though the landscape has been lit through a filter too large to see. Faces lose warmth. Green plants look darker. Bright surfaces seem sharp but drained. The effect is not simply lower brightness. It comes from the changing shape of the light source and the rapid decline in direct illumination. The scene becomes both clearer and less natural. Details remain visible, but the atmosphere around them feels wrong. This is the stage when attention leaves the sun and turns outward. The eclipse is no longer only above, it is in the air, the shadows, the temperature, and the behavior of living things. In open country or along a coastline, the moon's shadow may become visible as a dark mass on the horizon. It is not a cloud. It has no structure, no rain, and no edge shaped by wind. It is the absence of direct sunlight moving across Earth at great speed. The exact speed depends on the geometry of the eclipse and the position of the observer, but it is often far faster than anything travelling on the ground. Distant hills may darken first. A line of cloud may seem to vanish into shadow. Over the sea, ships may switch on their lights. Across a city, automatic lamps may awaken. These signals can arrive before the observer fully understands how dark the world has become. Adaptation hides the gradual change until artificial lights reveal it. The final minutes compress the entire experience. The crescent sun becomes thinner, and the visible world begins to lose its last connection to normal daylight. The horizon may remain bright beyond the approaching shadow, while the sky overhead deepens. The difference creates the impression that twilight is closing in from every direction. Unlike sunset, there is no single western glow. The sun remains above, but its light no longer reaches the ground directly. The geometry of the event becomes visible on the scale of the whole sky. Inside the shadow, darkness advances. Beyond it, daylight continues. The observer stands at the moving boundary between those two conditions. There is a physical reality behind every sensation. The cool air comes from reduced solar heating. The sharp shadows come from the narrowing solar crescent. The strange colours come from lower illumination and changing adaptation in the eye. The distant darkness comes from the moon's umbra, the central region of shadow where the sun will be fully covered. Yet explanation and experience do not cancel each other. The scientific cause makes the changes more precise, but it does not make them less powerful. The world is behaving exactly as orbital mechanics predicts, and still it feels as though the normal order has begun to loosen. This tension gives the approach its quiet force. Nothing supernatural occurs, but the natural event reaches so far into familiar perception that it feels almost impossible. The last direct sunlight often breaks into brilliant points around the uneven edge of the moon. Valleys on the lunar surface allow thin beams to pass for a moment, while mountains block the rest. These points shrink and vanish in rapid sequence. One final bead may remain, intense and white, set beside the dark lunar disk. Around it, the faint inner corona may begin to appear. The contrast is extreme, and the moment lasts only briefly. It is the final warning that the threshold is near. Safe eclipse viewers remain necessary until the bright photosphere is completely covered. Then the last bead disappears, the direct light is gone, and the landscape changes at once. Before that instant, however, there is a pause that feels longer than its measured duration. The crowd may grow quiet or restless. Cameras are adjusted. People look from the horizon to the sun and back again. Every visible sign points toward the same approaching event, yet the mind still has difficulty accepting what the sky is about to do. Daylight is one of the most stable conditions in ordinary life. It returns each morning, strengthens toward midday, and fades toward evening. The eclipse breaks this rhythm not by destroying the sun, but by placing a small nearby world precisely in front of it. The immense star remains unchanged. The moon does not produce darkness of its own. It merely interrupts the line of sight. And that interruption is enough to transform the atmosphere, the landscape, and the behavior of every witness within the path. The approach therefore carries its own lesson. Great changes do not always announce themselves with noise. Sometimes they begin as a notch in the sun, a cool breath of air, a sharper shadow, or a colour that seems slightly wrong. The signs gather slowly until they become impossible to ignore. Then the moving shadow arrives, not as a metaphor but as a real structure crossing Earth, and the final ordinary light is taken away. The world stands on the edge of totality, with the familiar sky still present and already beginning to disappear. When the last fragment of the sun disappears, the change is so abrupt that the mind has no time to turn it into a gradual event. One moment the landscape is held together by a thin, fierce thread of direct light. The next moment that thread is gone. Daylight does not fade in the usual manner. It is cut off. The sky darkens. The horizon burns with distant colour, and the place beneath the moon's shadow enters a form of night that has no evening and no dawn. The suddenness is the first great shock of totality. The partial phase may last for more than an hour, but the transition into full eclipse can happen in seconds. Years of planning, travel, weather watching, and anticipation narrow into one precise instant when the final point of the photosphere vanishes behind the moon. The bright bead contracts and goes out. At that moment the sun seems to cease being the familiar object that rules every ordinary day. In its place hangs a black disk surrounded by pale, delicate light. The response from a crowd often rises before thought. Cheers break out, voices fail. Some people laugh, some cry, and some fall into complete silence. Most observers know the geometry. They understand that the moon is passing in front of the sun, and that the sun itself remains unchanged. Yet knowledge does not prevent the body from responding to a sky that appears to have broken one of its deepest promises. The sun is still above the horizon, but its face is gone. The world is dark, but it is not night. The stars are present, but evening has not arrived. The senses receive conditions that do not normally exist together, and for a few moments the familiar categories of day and darkness no longer fit. The darkness of totality is also unlike midnight. It is usually not complete. The horizon may glow in a circle, because areas beyond the moon's narrow central shadow remain in sunlight. This creates the appearance of sunset in every direction, a ring of orange, rose, or pale gold surrounding the darkened landscape. Above that ring, the sky deepens toward grey, blue, or violet. Darkness occupies the center while daylight survives at the edges. The observer stands inside a moving island of shadow, looking outward toward a world where the sun still shines. This circular twilight reveals the shape of the event more clearly than any diagram. It shows that totality is local, temporary, and narrow. The entire planet has not entered night. Only one moving region has been detached from day. The light near the ground changes at the same instant. Artificial lights become visible, windows glow, and the landscape gains the muted contrast of deep twilight. Mountains become silhouettes. Water turns dark and reflective. Trees stand against the horizon as if evening has arrived without passing through sunset. Yet the sky overhead remains the center of attention because the corona has emerged. It surrounds the black moon with a brightness that is gentle compared with the solar surface but still unmistakable. Its shape is not a perfect ring. It may extend in streamers, loops, plumes, and fine structures shaped by the sun's magnetic field. Some features reach farther in one direction than another. The corona can appear white, silver, or softly luminous, with an inner region bright enough to seem almost solid, and outer strands fading into the dark sky. It is the strange light occupying the place where the sun should be. The moon itself appears completely black. Its surface reflects sunlight, but the side facing Earth during a solar eclipse is the night side. Against the corona, it has almost no visible detail. The result is a circle that looks less like a world than an opening. The eye knows it is the moon, a rocky body with mountains and craters, yet none of those features can be seen. The disk appears absolute, darker than the surrounding sky. And perfectly placed over the sun, the ordinary moon has texture and phase. The eclipsing moon becomes a pure shape, a dark boundary between Earth and the hidden star. Around its edge, small points of reddish light may sometimes appear. These are prominences, vast arcs of glowing solar gas extending beyond the sun's visible surface. Their colour comes from hot hydrogen, and their scale can be enormous, though from Earth they may look like delicate sparks. They offer another reminder that the sun has not vanished. It remains active behind the moon, with its atmosphere briefly exposed. The disappearance of direct sunlight also reveals bright planets and stars. Their visibility depends on the depth of the eclipse and the clarity of the sky, but several may appear around the darkened sun. Venus is often the first to emerge because of its brightness. Jupiter or Mercury may become visible, and bright stars can appear in positions usually hidden by daylight. Their sudden presence changes the scale of the scene. The eclipse no longer feels like one object crossing another. It becomes a view into the architecture of the solar system. The hidden sun occupies the center. The planets appear along the broad plane in which they orbit. The moon is close enough to cover the star, while distant points of light remain scattered beyond it. For a brief interval, relationships normally understood through charts become visible in the sky itself. The silence that sometimes follows the first cheers can be as striking as the darkness. A beach, field, desert, or a city filled with people may become still as attention gathers around the black sun. The duration is short, and every second feels exposed. There is no sense that the moment can be repeated immediately. The moon continues moving. The corona remains visible only while the solar surface is fully covered. The same geometry that creates the event also carries it toward its ending. This awareness gives totality a strange texture of time. The moment feels suspended, yet it is passing quickly. Some observers later remember it as timeless, while clocks record only a few minutes. Ordinary time is measured by change, distraction, and expectation. During totality, attention may become so complete that the usual markers disappear. There is only the dark sun, the pale corona, the ring of twilight, and the knowledge that the scene will vanish almost as soon as it has been understood. This is one reason totality can feel larger than its duration. It is also why attempts to photograph every moment can become a source of regret. Cameras preserve details that memory cannot hold, but the eclipse is too broad to fit inside a frame. Looking only through a screen can reduce the sky to an object, while the surrounding transformation goes unnoticed. The temperature, horizon, crowd, wind, and altered light are part of the same event. Totality rewards preparation. But it also demands presence. Once the sun is fully covered, the most powerful act is often simply to look. Safe viewing rules remain essential. During the partial phases, direct observation of the sun requires proper eclipse filters because even a narrow crescent can damage the eyes. Only during complete totality, when the bright photosphere is entirely hidden, can the eclipse sun be viewed without those filters. The moment direct sunlight begins to return, protection must be used again. Totality begins when the last bright bead disappears and ends when the first one returns. The end approaches with the same speed as the beginning. The corona may brighten on one side, and a sharp point of white light appears at the lunar edge. After minutes of darkness, the first ray of direct sunlight feels impossibly strong. It floods the landscape, erases the stars, and begins restoring blue to the sky. Shadows soften, colours regain warmth. The ordinary sun reappears as a thin crescent and begins its slow escape from behind the moon. Totality is over, though the partial eclipse continues. The transformation in reverse happens almost too quickly to follow. A single point of light becomes a crescent, and the darkness that seemed complete a moment earlier retreats across the land. What remains is not only memory, but contrast. The observer now understands how much of the familiar world depends on direct sunlight, because its absence has been experienced all at once. Daylight is no longer an invisible background. It becomes something physical, powerful, and fragile enough to vanish when one nearby world crosses the correct line in space. The brief darkness reveals the architecture of ordinary life by interrupting it. It shows the sun not as a decorative object in the sky, but as the source that defines colour, rhythm, warmth, and the difference between day and night. Totality lasts only minutes. Yet within those minutes, the most stable element of daily experience is removed and restored. That is why the moment feels less like watching an eclipse and more like witnessing the world become unfamiliar, then receiving it back. A total solar eclipse does not merely darken the familiar sky. It replaces it with a sky that seems to belong to another world. The change begins overhead, where the blue of day drains toward grey, violet, or a deep, muted blue. The exact colour depends on the atmosphere, the weather, and the brightness of the surrounding horizon, but the impression is often the same. The sky has not become ordinary night. It has become something suspended between states, a brief atmosphere with no natural hour. The sun remains above the horizon, yet its direct light is gone. The landscape below is dark enough for lamps to glow, while the distance still carries the colours of daylight. This combination creates a sky that daily experience never provides. It is neither afternoon nor evening, neither storm nor twilight, neither darkness nor day. It is totality, and the senses have no familiar category large enough to contain it. High overhead, the moon appears as a black circle fixed against the faint radiance of the corona. Around it, the sky may look cool and almost metallic. Near the horizon, however, warmer colours survive. Orange, amber, rose, and pale gold may form a continuous ring because sunlight still reaches the atmosphere beyond the edge of the moon's shadow. Every direction can carry the glow of sunset. The effect is not produced by the sun setting in several places at once, but by the observer standing inside a narrow column of darkness and looking outward toward regions that remain illuminated. This ring of colour defines the boundary of the shadow. It turns the horizon into a distant map of where daylight continues, while the centre of the sky reveals where direct sunlight has been removed. The geometry is simple, but the visual result feels impossible. In ordinary twilight, brightness gathers near one side of the horizon and fades across the sky. During totality, the glow can surround the observer completely, enclosing the dark landscape within a circle of distant day. The colours also seem more intense because the central sky has dimmed. Warm light near the horizon stands against the cooler darkness above, creating a contrast that photographs often struggle to preserve. The eye moves from the black sun to the violet sky, from the sky to the glowing distance, and from the horizon back to the stars appearing where blue daylight had hidden them moments before. The appearance of stars and planets in the middle of day deepens the sense that the sky has opened. They have not arrived suddenly. They have remained in their places all along, concealed by scattered sunlight. When the sun blocks the bright solar surface, the atmosphere above the path of totality darkens enough for the brightest of them to emerge. Venus may appear first, sharp and steady against the dim sky. Jupiter may follow, or Mercury may become visible close to the hidden sun. Bright stars can appear farther away. Their positions depend on the season and the geometry of the eclipse, but their presence always changes the scale of the event. The black disk is no longer an isolated spectacle. It becomes the centre of a larger arrangement stretching across the sky. Planets appear along the broad path followed by the sun, a path reflecting the flat structure of the solar system. The moon, sun, and planets seem briefly assembled in one visible field. Under normal conditions, this structure exists mostly in diagrams, calculations, and mental models. During totality, it becomes part of the landscape. The planets shine because they reflect sunlight, even while the sun itself appears dark. The source of their light is hidden behind the moon, yet its influence remains visible across space. The eclipse does not extinguish the sun. It blocks one narrow line of sight from one moving region on Earth. These surviving traces reveal the difference between appearance and reality from the ground. The sun seems to vanish, but the wider solar system remains illuminated. The sky therefore presents both the illusion of disappearance and the evidence that nothing has truly gone. This layered view is one reason the scene feels so deep. The black moon sits in the foreground, only a few 100,000 miles away. The hidden sun lies vastly farther beyond it. The visible planets occupy still other distances, and the stars belong to regions far outside the solar system. Ordinarily, the sky flattens these distances into a single dome. Totality gives them a new order. The moon becomes unmistakably near because it covers the sun. The planets become neighbouring worlds because they appear around it. The stars become a more distant background. For a few minutes, depth enters the sky. A familiar ceiling becomes a layered view through space. The colours of the landscape also contribute to the sense of displacement. Grass may look almost black. Skin tones become pale or grey. Water loses its daytime sparkle and reflects the dim sky like polished metal. White surfaces can remain surprisingly bright, while reds and greens seem subdued. Human colour vision depends on the amount and character of available light, so the rapidly changing conditions alter how the world is perceived. The eclipse does not repaint the landscape, but it changes the visual system through which the landscape is known. The same beach, field, street, or desert becomes unfamiliar because its colours no longer belong to the expected hour. The mind recognizes every object and still experiences the whole scene as strange. It can transform a familiar place so completely that it feels newly discovered. Sound may sharpen as vision loses certainty. The first cheers can fade into murmurs or silence. Small sounds from the crowd become distinct against the darkened air. With the ordinary sun removed, awareness spreads across the environment. A distant voice, the click of a camera, the movement of leaves, and the sudden quiet of animals all become part of the same altered world. The sky commands the eyes, but totality reaches every sense. The coolness of the air, the dimness of the ground, and the ring of twilight reinforce one another until the event feels complete. Even the direction of light becomes difficult to understand. During normal day, shadows reveal where the sun is. During totality, the dominant direct source is hidden, and much of the remaining light comes indirectly from the corona, the horizon, and the atmosphere beyond the shadow. Objects may seem softly lit from several directions. The horizon glows around the observer instead of from one side. The landscape loses the ordinary visual clues that define position and time. The result is not confusion in a practical sense, but a temporary weakening of familiar orientation. The world remains stable beneath the feet, yet the sky no longer explains it in the usual way. Ancient witnesses often interpret eclipses through the beliefs available to them, but modern scientific understanding does not erase this sensory disruption. It only reveals how extraordinary ordinary perception is. Every normal day is built from a stable arrangement of sunlight, atmosphere, colour, and shadow. Totality removes one part of that arrangement and exposes how much depends on it. The event feels alien not because nature has stopped following its laws, but because those laws have created a condition rarely encountered by human senses. The same precision that makes the eclipse predictable also makes the experience unique. The moon must cover the bright photosphere completely. The observer must stand within the central shadow. The atmosphere must remain clear enough to reveal the full sky. When these conditions meet, the result is a natural scene with no common equivalent. A dark sun hangs above a twilight world. Planets shine at midday. Sunset surrounds the horizon. The landscape cools under a shadow moving across Earth, while daylight continues only a short distance away. No photograph can fully combine these elements because the meaning lies in their simultaneity. The black disk alone is not the eclipse. The corona alone is not the eclipse. The coloured horizon, the appearing planets, the altered air, and the strange light are not separate decorations. Together they form the sky of totality. This sky lasts only until the first point of direct sunlight returns. Then the stars vanish, the planets fade, the horizon loses its circular glow, and blue begins to spread overhead. The unfamiliar world closes almost immediately. What remains is the knowledge that such a sky exists, hidden inside an exact alignment and available only from a narrow moving path. A person may spend decades beneath the sun without seeing it. Then, for a few minutes, the daylight sky reveals an entirely different face. and the ordinary heavens can never seem quite as complete again. The sun's outer atmosphere is always present, yet almost no ordinary day allows it to be seen. It extends far beyond the bright surface that defines the familiar solar disk, spreading into space in structures shaped by heat, motion, and magnetic fields. Under normal conditions, this atmosphere is hidden because the visible face of the sun is overwhelmingly brighter. Daylight floods the sky, scattering through Earth's atmosphere and erasing the faint light surrounding the star. During totality, the moon removes that glare with extraordinary precision. The solar surface disappears, the sky darkens, and the corona emerges. It is not created by the eclipse. It has been there all along. The eclipse simply reveals what brightness conceals. This reversal gives the corona much of its power. The moon seems to erase the sun, yet in doing so it uncovers a larger and stranger sun than the one known from daily experience. The corona can appear like a silver crown, a pale flame, or a network of fine streamers extending from the black lunar disk. No single shape defines it because its structure changes with the sun's magnetic activity. At some eclipses, long rays stretch outward along the solar equator while shorter plumes rise near the poles. The pattern reflects the invisible magnetic field that threads the solar atmosphere. Charged particles move along these field lines, and glowing plasma traces the architecture of forces that cannot otherwise be seen directly. The result looks delicate, but the conditions within it are extreme. The corona reaches temperatures of more than 1,000,000 degrees, far hotter than the visible solar surface below. This remains one of the central puzzles of solar physics. Heat usually flows from hotter regions to cooler ones, yet the outer atmosphere is far hotter than the layer beneath it. Waves, magnetic reconnection, and the release of stored magnetic energy all appear to play roles. But the full process remains an active field of research. Totality, therefore, reveals not only beauty, but an unresolved scientific problem. The pale light around the moon carries evidence of a violent environment where magnetic fields twist, break, and reconnect, releasing energy into the surrounding plasma. The apparent softness is deceptive. The corona is a region of motion, heat, and constant escape. From it comes the solar wind, a stream of charged particles flowing outward through the solar system. This wind reaches Earth, shapes planetary magnetospheres, contributes to auroras, and influences the space through which spacecraft travel. The corona often seems finely woven, as though made of countless bright threads. These are not solid strands, but concentrations of glowing plasma organized by magnetic fields. Some form loops rooted in active regions on the sun. Others extend outward into long streamers that narrow with distance. Near the moon, the corona may shine strongly. Farther away, it fades gradually into the sky. Cameras can capture separate exposures for different regions, but a single image often loses either the bright inner detail or the faint outer extensions. This is one reason photographs rarely reproduce the complete impression. The corona is not a simple halo with a fixed boundary. It has texture, asymmetry, and an almost transparent quality. The black moon gives it a sharp center, while the outer light dissolves without a clear edge. Along the lunar rim, smaller features may add color to the silver scene. Solar prominences can rise beyond the hidden surface as red or pink arcs. These structures are made of cooler, denser plasma held above the sun by magnetic fields. They may form loops far larger than Earth, though during the eclipse they appear as tiny flames around the edge of the moon. Their color stands out because most of the corona is white. For a moment, the sun's layered atmosphere becomes visible at several scales. The dark moon in front, the narrow reddish prominences at the edge, the bright inner corona beyond them, and the long outer streamers fading into space. the eclipse offers only a brief sample of a star in continuous motion. Scientific instruments can study the corona from space without waiting for totality. Coronagraphs block the bright solar disk with an artificial mask, creating a permanent imitation of an eclipse. Spacecraft observe the sun in wavelengths invisible to human eyes, revealing hot loops, eruptions, and sources of solar wind. Yet natural totality still has scientific value because the moon blocks the sun more cleanly than most artificial devices. Its apparent edge allows observations extremely close to the solar surface, where important structures begin. During eclipses, researchers have measured coronal brightness, temperature, composition, and magnetic behavior. They have tested instruments, searched for faint features, and compared the corona with models built from space observations. Historically, eclipses have also allowed discoveries difficult under ordinary daylight. The corona's green spectral line once led scientists to suspect an unknown element before it was explained by highly ionized iron under extreme coronal temperatures. Eclipse expeditions have tested ideas about gravity, studied the solar atmosphere, and refined understanding of light and matter. Still, the corona's deepest impact is not limited to measurement. It changes the apparent identity of the sun. The everyday sun is a bright circle, visually simple and nearly impossible to examine directly. It appears stable because its surface brightness hides the complexity beyond it. During totality, that simple circle is replaced by a dark center and an extended atmosphere many times wider than the hidden disk. The star suddenly seems larger, more structured, and more alive. The corona turns the sun from a distant source of daylight into a physical object with layers, fields, and an atmosphere reaching outward. It reveals that the edge seen on ordinary days is not the true edge of the sun. There is no sharp boundary where the star simply ends. Its influence continues through the corona, into the solar wind, and across the space surrounding every planet. Earth exists inside that extended solar environment. The eclipse makes this relationship visible. The same streamers shining around the moon belong to the star whose particles interact with Earth's magnetic field. The same magnetic activity shaping the corona can produce solar eruptions that disturb satellites, radio communication, and electrical systems. The quiet silver light is connected to forces capable of affecting a technological civilization millions of miles away. Its beauty comes partly from this union of delicacy and power. Fine rays cross the dark sky, but they arise from temperatures and energies beyond ordinary experience. The corona looks calm because its scale is vast and its distance is great. As totality continues, the eye begins to notice that the corona is not evenly bright. Some regions contain dense streamers, while others are darker, creating gaps and curves that hint at the magnetic field. Polar plumes may spread like fine brushes. Helmet-shaped streamers may rise over active regions. During periods of high solar activity, the corona can surround the sun in many directions. During quieter periods, it may stretch more strongly along a broad equatorial band. Each eclipse therefore reveals a different solar atmosphere. The geometry of the moon and Earth repeats, but the corona never appears in exactly the same form. It records the changing state of the sun at that moment in its cycle. An observer is not only seeing totality, but a temporary portrait of the star. This uniqueness deepens the sense of rarity. Another eclipse may come years later, but its corona will belong to a different day, shaped by different magnetic fields and different patterns of solar activity. The hidden atmosphere does not wait in a fixed arrangement for the moon to uncover it. It evolves continuously, visible through instruments but revealed to human sight only under the precise darkness of totality. Then the first point of sunlight returns, and the corona vanishes almost instantly. It is not destroyed. The glare simply overwhelms it again. The outer atmosphere remains around the sun, unchanged by the return of day, but the eye loses access to it. This disappearance is as instructive as its arrival. It shows how much of reality remains hidden, not because it is distant or absent, but because something brighter stands in front of it. Totality briefly removes that barrier. The familiar sun disappears, and a deeper sun takes its place, vast, magnetic, restless, and connected to every world moving through its influence. For a few minutes, the invisible architecture of the star becomes visible, and the sky reveals that concealment can sometimes be the condition that allows a greater form of light to appear. During totality, the sky briefly stops looking like a flat ceiling and begins to resemble a system of worlds arranged across depth. The black moon occupies the foreground. The hidden sun lies far beyond it. Bright planets appear at different points along the sky, and distant stars emerge behind them. Nothing has changed position in any sudden way. The planets haven't moved into line for the eclipse, and the stars have not approached Earth. The disappearance of daylight simply removes the glare that usually hides them, yet the result creates an unusual perspective. For a few minutes, the observer no longer seems to stand beneath a single bright object. The observer seems to look outward through the structure of the solar system itself. The moon's dark disk is the nearest world in the scene, close enough to cover the sun almost exactly. Its presence makes distance visible. The sun appears similar in size only because it is much farther away. This balance between apparent size and true scale produces the eclipse, but during totality it also reveals the layered nature of the sky. The black circle is not a hole. It is a nearby rocky body crossing in front of a star. The corona belongs to that star and surrounds the moon only from Earth's line of sight. The planets shining nearby are separated from both by enormous distances. The stars beyond them lie farther still. What ordinarily appears as one smooth dome becomes a sequence of overlapping regions in space. Diagrams show the arrangement from the side, with the sun, moon, and Earth placed along a line. Totality places the observer inside that diagram. The geometry is no longer abstract. The moon blocks the sun directly. The corona surrounds the lunar edge. The planets remain scattered along the broad path followed by the sun across the sky. That path, known as the ecliptic, reflects the flattened shape of the solar system. Most planets orbit the sun within roughly the same plane because they form from a rotating disk of gas and dust. From Earth, their paths therefore remain close to the sun's apparent route through the constellations. During ordinary daylight, this structure is hidden. During totality, it can appear all at once. Venus may shine on one side of the eclipsed sun, while Jupiter or Mercury appears elsewhere. Their exact positions vary, but their presence turns the event into more than an alignment of three bodies. It becomes a temporary portrait of the planetary family. The planets seem arranged around the invisible center that governs their motion. The sun itself is hidden, yet its authority remains visible. Every bright planet reflects its light. Every orbit depends on its gravity. The solar wind continues flowing outward through the corona. The eclipse removes the sun's visible surface but leaves the evidence of the sun everywhere. This creates one of the event's deepest visual paradoxes. The central object cannot be seen, yet the entire scene reveals its influence. The planets glow because the sun illuminates them. The moon appears black because its sunlit side faces away from Earth. The corona shines because hot solar plasma surrounds the hidden star. Even the ring of twilight on the horizon exists because sunlight continues to reach the atmosphere beyond the moon's shadow. The sun is absent only in the narrowest visual sense. Its light and gravity organize everything in view. from the ground. This can feel like looking back toward the solar system from an imagined distance. The familiar sun is no longer a blinding disk that erases its surroundings. It becomes a dark center around which planets and stars are visible. The perspective resembles no actual view from deep space, because the corona and eclipse depend on standing on Earth behind the moon's shadow. Yet emotionally, the scene can produce a sense of removal. Earth seems less like the fixed center of experience and more like one world among many. The observer remains on the surface, held by gravity and surrounded by air, but the sky no longer confirms ordinary human scale. The visible arrangement suggests motion on several levels at once. The moon travels around Earth, Earth moves around the sun, the planets follow their own paths, the sun carries the entire system through the galaxy. The stars beyond are also moving, though their distances make that motion difficult to perceive. Totality compresses these motions into one still-looking image. For a few minutes, everything appears suspended. Yet the eclipse exists only because everything continues to move. The stillness is an illusion produced by coordinated motion. The moon's shadow crosses Earth, because the moon advances in its orbit while Earth rotates beneath it. The planets hold their places in the darkened sky only for the brief interval during which totality lasts. The stars seem fixed because their movement unfolds across timescales and distances far beyond the event. The sky appears frozen, but the entire system is in motion. This contrast can weaken the ordinary sense that Earth is stationary. Daily life gives little direct evidence of the planet's speed. The ground feels solid. The horizon appears stable. The sun seems to cross the sky while Earth remains still. Astronomy reverses this impression through measurement and reason, but totality gives it a physical form. The eclipse depends on Earth being a moving world. Its shadow path is calculated from rotation, orbit, distance, and geometry. The changing sky becomes a reminder that the ground beneath the observer is part of the same celestial machinery. The planet is not watching the event from outside, it is one of the bodies creating it. This is why the alignment can feel like a temporary escape from the usual viewpoint. Human life is normally organized around local distances. A room, a road, a coastline, or a city defines the scale of attention. Even the sun and moon often appear as ornaments placed on a distant surface. During totality, their true relationship becomes harder to ignore. The moon is a world passing nearby. The sun is a star whose atmosphere extends millions of miles into space. The planets are other worlds reflecting the same light. Earth is one more moving sphere inside the arrangement. The event makes familiar facts difficult to keep at an emotional distance. The sense of looking from outside the solar system is therefore not literal. It is a change in perspective. The black moon shows proximity. The corona shows the sun's extended atmosphere. The planets show the plane of orbit. The stars show the deeper background. The horizon shows the edge of the shadow. Each feature belongs to a different scale, yet all become visible at once. The result resembles a cosmic diagram drawn in light and darkness across the sky. This diagram is incomplete. Most planets may remain below the horizon or too faint to see. The distances between visible objects cannot be judged accurately by sight. The stars appearing near the sun are not physically close to it. They only share a direction from Earth. The sky still compresses 3 dimensions into 2. Yet the eclipse provides enough clues to make depth imaginable. The moon's coverage reveals the line between near and far. The planets' positions reveal the broad plane of the system. The stars provide a background so distant that the entire solar system becomes a foreground against them. The mind begins to place Earth within layers of space. That shift can feel both expansive and unsettling. The ordinary sky protects human scale by hiding most celestial structure in daylight. The sun dominates, and everything else recedes. Totality removes that dominance without removing the sun's influence. Suddenly the system appears larger, more populated, and less centered on Earth. The observer is not looking up at a display arranged for the planet. The observer is looking outward from one moving location within a system that continues whether it is seen or not. The eclipse offers no message, but its geometry creates an unmistakable perspective. Earth is not separate from the heavens. The planet belongs to them. The shadow crossing the ground is cast by another world. The light surrounding that shadow comes from a star. The points appearing nearby are planets and distant suns. The scene joins the local and the cosmic without requiring imagination to cross the distance. When totality ends, the view collapses quickly. The first direct sunlight returns. The stars disappear. The planets fade, and the solar system becomes invisible behind blue daylight once more. The moon continues across the sun, but the layered architecture is lost. What remains is the memory of having seen the familiar sky rearranged into depth. For a few minutes, Earth no longer feels like a platform beneath the universe. It feels like a moving part within it, carried through space under the shadow of a neighbouring world, circling a hidden star whose light binds the entire scene together. A total solar eclipse is often described as beautiful, but beauty alone does not explain the intensity of the reaction it can produce. The deeper response is awe, a state that arises when the mind encounters something vast enough to exceed its ordinary frame of reference. Vastness can be physical, as in the scale of the sun, the distance of the planets, or the speed of the moon's shadow. It can also be conceptual, as in the realization that a simple alignment links human perception to motions unfolding across millions of miles. During totality, these forms of vastness arrive together. The sky changes, the landscape darkens, the temperature falls, the planets appear, and the corona surrounds a black disk where the sun should be. The mind recognizes the event and still struggles to contain it. Awe begins in that struggle. It is not ignorance, and it does not require belief in anything supernatural. It is the feeling that established mental categories are too small for what is being perceived. Psychologists often describe awe as involving two elements: perceived vastness and a need for mental adjustment. The first element is easy to find in an eclipse. The star at the center of the solar system is hidden by a nearby world, and the shadow of that world moves across Earth. The second element appears when the mind tries to reconcile known facts with direct sensation. The sun has not gone out, the moon has not changed size, night has not truly arrived. Yet the senses report a black sun, a darkened world, and stars at midday. The brain must revise its immediate model of the scene. For a few minutes, ordinary expectations fail, and attention becomes unusually complete. This intense attention helps explain why eclipse memories often remain vivid for decades. Everyday experiences compete with thought, habit, and distraction. Totality gathers perception into a single event. The body notices the falling temperature, the altered wind, the dim landscape, the changing sounds, and the unfamiliar sky. The mind cannot easily turn away because the event is brief and irreversible. Every second feels significant. This concentration can create the impression that time has slowed or stopped, even while the moon continues steadily across the sun. The clock measures minutes, but memory records a much larger interval, because so much attention has been compressed into it. Awe also changes the apparent size of the self. Under normal conditions, attention is often organized around personal concerns, plans, discomforts, and social position. A total eclipse introduces a scale on which these concerns become temporarily small. The effect is not necessarily humiliating or frightening. It can be relieving. The individual remains present, but no longer occupies the center of experience, the sun, moon, earth, atmosphere, and distant planets form a system that does not depend on any witness. The eclipse would occur over an empty ocean with the same precision. Recognizing this can loosen the ordinary pressure of self-importance. Personal life does not disappear, but it is placed inside a wider setting. This reduction in self-focus is sometimes called the small self effect. Research on awe suggests that people in this state may feel less preoccupied with their own immediate needs and more connected to larger groups, nature, or humanity as a whole. The eclipse offers especially strong conditions for such a response because the source of awe is shared. A crowd may contain strangers of different ages, backgrounds, and beliefs, but all stand under the same shadow. When totality begins, attention turns upward together. Voices rise together or fall silent together. The event removes many of the signals that usually separate one person from another: status, argument, and routine briefly lose importance beside the black sun. The result can feel communal without requiring agreement about anything except the reality of the sky. This shared awe may also influence behavior after the event. Experiments and field studies suggest that awe can increase feelings of connection and, in some circumstances, generosity or willingness to help. The effect is not magical and does not permanently transform every observer. Human behavior is too complex for a few minutes of darkness to erase conflict or selfishness. Yet the emotional state can create a temporary widening of perspective. When the self feels smaller, other people may seem less distant. When a group responds to the same vast event, the boundary between private experience and collective experience becomes thinner. The eclipse does not deliver a moral lesson by itself, but it can create a mental space in which ordinary divisions feel less absolute. The body contributes to this process. Awe often includes physical sensations such as chills, changes in breathing, tears, a tightening in the chest, or a sense of stillness. These reactions can occur even when the observer expects them and understands their cause. The nervous system responds not only to danger but also to sudden significance. During totality, the rapid loss of daylight may activate ancient responses to unexpected environmental change, while the visible corona and surrounding twilight direct attention toward beauty rather than immediate threat. The result is a mixture of alertness and wonder. The heart may race while the body remains still. The eyes search the scene while thought becomes quiet. This combination helps give the event its unusual emotional force. Awe can contain fear without becoming terror. The black sun may look ominous, and the abrupt darkness can feel deeply wrong, especially during the first encounter. Yet prediction and preparation provide safety. The observer knows that the light will return. This knowledge allows the strangeness to be experienced without complete alarm. The event approaches the boundary between beauty and fear, then remains on the side of wonder. It shows how closely these emotions are related. Both arise when the familiar order is disrupted. The difference lies in whether the disruption appears survivable, meaningful, and open to attention. Totality is brief, known, and surrounded by scientific understanding, so its darkness can be entered without losing trust in the world. The return of sunlight completes the emotional arc. A brilliant bead appears, the corona vanishes, and daylight floods back across the landscape. Relief may arrive even when no conscious fear has been felt. The world becomes familiar again, but familiarity now carries new weight. The ordinary sun appears astonishing because its absence has just been experienced. Daylight, often unnoticed, returns as a physical gift, colour, warmth, and shadow recover their usual forms, or therefore does not end with the black sun. It continues in the restoration of the normal world. The event reveals that ordinary conditions are not emotionally neutral once they have been removed and returned. This may explain why eclipse chasers speak less about collecting sights than about renewing a state of mind. The scientific facts remain the same from one eclipse to another. The moon crosses the sun, the shadow moves across Earth, and the corona appears. Yet the emotional experience can deepen because each event reconnects knowledge with direct perception. The observer does not merely remember that Earth belongs to a solar system. The observer feels that belonging again. The effect may fade in daily life, but the memory becomes a reference point, proof that perception can still be reorganized by the natural world, or is sometimes treated as a luxury, an emotion reserved for rare landscapes, great art, or unusual travel. In reality, it may serve a basic psychological function. It interrupts narrow attention. It exposes the limits of familiar assumptions. It reminds the mind that reality is larger than the problems occupying the present moment. A total solar eclipse performs this function with unusual completeness because it alters the most stable background of life. The sky itself changes. The sun disappears. The planets emerge. The horizon glows in every direction. The event does not ask for interpretation before producing its effect. Meaning follows sensation. The lasting value of totality therefore lies partly in what it does to scale. It makes the individual feel small without making life feel meaningless. Instead, smallness becomes a form of connection. A brief human life exists within the same universe that produces stars, planets, shadows, and precise alignments. The observer is not outside that system and not beneath it in any absolute sense. The observer is made of the same matter, stands on one of its worlds, and witnesses one of its passing geometries, or gathers these facts into a single feeling. For a few minutes, knowledge becomes immediate. The self becomes quieter, and the wider universe feels less like an idea than a surrounding reality. The first total solar eclipse often becomes a dividing line in memory. Before it, an eclipse may seem like one remarkable event among many, a rare entry on a calendar and a reason to travel if circumstances allow. After it, the same event can acquire a different weight. The observer knows that a description is not enough, that photographs do not reproduce the scale, and that the abrupt disappearance of daylight cannot be understood through percentage, duration, or distance alone. This knowledge creates a new kind of anticipation. The next eclipse is no longer an abstract date. It is a future meeting with a state of the world that has already proved capable of changing perception. This is how eclipse chasing begins. The term can sound excessive, as though the pursuit belongs only to specialists or collectors. In practice, eclipse chasers include astronomers, photographers, families, travelers, teachers, engineers, artists, and people with no formal connection to science. What unites them is not a profession, but a memory. They have stood beneath the central shadow and discovered that a few minutes can justify years of preparation. Once that judgment has been made through direct experience, the long journey begins to seem reasonable. Total solar eclipses occur somewhere on Earth every few years, but they do not arrive where most people happen to live. The path may cross an ocean, a desert, a high plateau, a tropical island, or a remote stretch of countryside. Reaching it can require flights, trains, buses, boats, rental cars, border crossings, and long drives toward a narrow strip on a map. The destination is chosen not for a monument or a city centre, but for geometry. A traveller may cross half the planet to stand in an empty field because that field will be dark for a few minutes while the land beyond it remains in daylight. This reversal of ordinary travel gives Eclipse chasing its unusual character. The place matters deeply, yet mainly because of what the sky will do there. Planning begins with the path of totality. Maps show where the moon's central shadow will cross Earth and how long totality will last at different points. The centre line usually offers the longest duration, but duration is only one factor. Weather becomes equally important. A location with slightly shorter totality and a higher chance of clear skies may be more attractive than a centre-line site known for clouds. Historical climate records are studied. Seasonal rainfall, coastal fog, mountain weather, desert dust, and local cloud formation all enter the decision. The event is predictable, but visibility is not. This uncertainty keeps every journey fragile. The shadow will arrive on schedule, yet a single cloud can conceal it. Eclipse chasers therefore learn to plan with precision and remain ready to abandon the plan. Vehicles are kept fueled, alternate routes are marked, weather forecasts are checked repeatedly as the day approaches. A group may wake before dawn and drive hundreds of miles toward a break in the clouds. The final observation site may be a roadside, a farm, a schoolyard, or a patch of open land chosen only hours earlier. This mobility is part of the pursuit. The eclipse is fixed by celestial mechanics, but success depends on reading the atmosphere and moving through the world below it. When the sky clears, the uncertainty increases the emotional force of totality. The sight has not been guaranteed. It has been recovered from chance. Even experienced eclipse chasers do not become immune to the event. Familiarity may improve preparation, but totality remains too brief and too complete to become ordinary. Each eclipse has a different corona, shaped by the changing magnetic condition of the sun. The surrounding landscape is different. The horizon may be ocean, mountain, forest, desert, ice, or city. The duration changes. The planets occupy new positions, and the weather alters the color of the sky. One eclipse may arrive in still air over a tropical beach. Another may cross a cold plain under thin clouds. Another may darken a crowded street where thousands cheer from rooftops. The central geometry repeats, but the experience does not. Memory begins to compare them without reducing them to a ranking. One corona may appear broad and symmetrical. Another may stretch in long streamers. One approach may be visible as a dark wall crossing distant hills. Another may be hidden until the final seconds. One crowd may erupt in noise, while another falls silent. The differences make every eclipse a new encounter, rather than a copy of the first. There is also a rhythm to the return. The partial phase begins slowly, and experienced observers recognize the sequence. Filters go on. The first contact appears. Crescent images form beneath leaves. The air cools. The light becomes thin and metallic. These signs are familiar, yet they do not weaken anticipation. Instead, they act like steps leading toward a known threshold. The observer understands what's coming and also knows that understanding will not control the reaction. As the last minutes arrive, the body responds again. Attention sharpens. Conversation fades. The horizon is checked for the approaching shadow. Then the final sunlight disappears, and the old astonishment returns in a form that feels both remembered and new. The pursuit is therefore not simply an attempt to repeat pleasure. It is an attempt to revisit a perspective that daily life gradually closes. After an eclipse, the memory of cosmic scale may remain vivid for months or years, but ordinary concerns eventually gather again. Schedules, arguments, work, loss, and routine restore the self to the center of attention. Totality interrupts this restoration. It returns the observer to a scene in which Earth is visibly one moving world among others, and the human lifespan occupies only a small interval within celestial motion. Eclipse chasers often speak of the event as a renewal because it restores this wider frame. The journey itself also becomes part of the meaning. Reaching the shadow creates encounters with unfamiliar landscapes and communities. Travelers gather in towns that may never host such crowds again. Local residents open fields, schools, parks, and roads. Languages mix beneath the same sky. Scientists stand beside children, tourists, farmers, and residents who have stepped outside their homes. The path of totality ignores political boundaries, even as people cross those boundaries to reach it. The shadow enters one country, leaves it, crosses water, and arrives somewhere else without recognizing any division drawn on a map. Following it makes those divisions feel temporary. The destination is shared because no one can possess the event. Wealth can buy easier travel and better equipment, but it cannot extend totality or command clear weather. Every observer within the path receives the same moving shadow. This equality is imperfect, since access to travel is unequal. Yet the experience itself remains resistant to ownership. No private view can contain the whole sky. No ticket can make the corona brighter. No status can slow the moon. The eclipse offers its brief darkness to whoever stands in the correct place and looks up safely. That simplicity helps explain the loyalty it inspires. The pursuit may require money, time, and effort, but the reward is not an object. Nothing can be carried away except images, measurements, and memory. There is also an acceptance of disappointment. Some journeys end beneath clouds. The landscape darkens, the temperature falls, and the crowd knows that totality is occurring above, but the black sun remains hidden. Years of preparation may produce only a dim sky and a brightening horizon. Yet many chasers return after such failures. The disappointment is real. But it does not invalidate the pursuit. It reveals the event's independence. Nature does not owe visibility to effort. The eclipse happens whether it is seen or not. Returning means accepting that uncertainty again. This willingness gives the chase a quiet seriousness. The goal is not control, but presence. Eclipse chasing can appear irrational when measured only by duration. Several days of travel may lead to less than 3 minutes of totality. Costs may be high, routes difficult, and weather uncertain. Yet duration is a poor measure of significance. A brief event can reorganize memory more deeply than a long period of routine. The value lies not in how long the shadow remains, but in how completely it changes the world while it is present. Those who return are not chasing minutes. They are chasing the rare condition in which the familiar sun becomes strange. The planets appear in daylight, and the scale of life widens without abstraction. Each journey begins with a date on a map and ends, if the sky allows, with the same impossible transformation. The shadow arrives, the corona opens, and the observer remembers why the distance was crossed. A total solar eclipse is seen through individual eyes, but it rarely feels like an individual event. Long before totality begins, people gather along roads, beaches, fields, rooftops, parks, school grounds, and open stretches of land. Some arrive with telescopes and cameras. Others bring folding chairs, blankets, food, and cardboard eclipse viewers. Families stand beside astronomers. Travelers speak with local residents. Children wait near people who have crossed oceans for the same few minutes. The gathering may begin as a collection of separate plans, but the approaching shadow gradually gives everyone a common direction. Heads turn toward the sun. Watches are checked, clouds are studied, conversation narrows around whether the sky will remain clear. A temporary community forms before anyone intends to create one. It is built not from shared history, language, politics, or belief, but from shared attention. Everyone is waiting for the same light to disappear. This form of gathering is unusual because the event cannot be divided. A concert can be heard from different seats, and a landscape can be visited across many seasons. Totality arrives once at one time and covers everyone within the shadow together. The moon does not perform separately for each observer. It places an entire region under the same altered sky. The temperature falls for everyone. The shadows sharpen for everyone. The final bead of sunlight vanishes above every face turned upward. In that moment, the crowd does not merely watch the same object. It enters the same environment. Darkness becomes communal. The first response is often sound. Cheers rise from beaches and city streets as the sun disappears. The noise may begin in one part of the crowd and spread outward, carried by surprise more than intention. Even experienced observers can join it. Hundreds or thousands of people release breath, laughter, cries, or applause at once. Then the sound may fall away. The corona appears, planets emerge, and a silence gathers that feels different from the quiet before the eclipse. It is not the silence of uncertainty. It is the silence of attention too complete for speech. Strangers stand shoulder to shoulder without needing to explain what they are seeing. The black sun provides the entire subject. Shared awe has a physical presence in such moments. One person may feel the crowd through its noise, stillness, or movement, but also through the knowledge that countless separate minds are meeting the same impossible scene. Each observer notices different details and carries different memories, yet those private experiences overlap beneath the shadow. A person looking at the corona knows that the stranger nearby is also looking at it. That fact can make the event feel larger. The sky is not only changing above one life, it is changing above a field of lives at once. This is why photographs of eclipse crowds can be as moving as photographs of the eclipse itself. Faces tilt upward, expressions open, ordinary social posture disappears. People who might never speak to one another share the same vulnerability before scale. The eclipse does not erase difference or cure division. When daylight returns, political, economic, cultural, and personal conflicts remain. Yet totality can reveal how quickly some boundaries weaken when attention turns toward something no group controls. The moon's shadow crosses borders without recognizing them. It moves over wealthy districts and poor villages, over farmland and highways, over places divided by history and law. Human maps determine how people reach the path, but they do not determine the path itself. The shadow belongs to celestial geometry. Standing beneath it can make national and social divisions seem less absolute, not because they are unreal, but because they exist inside a larger physical world that does not follow them. This perspective becomes especially visible when people travel. Eclipse routes bring visitors into towns that may be unknown beyond their region. Hotels fill, fields become campsites, and local roads carry vehicles from distant places. Residents may open private land, organize viewing areas, teach safe observation, and prepare for crowds far larger than usual. Schools and museums hold public events. Scientists explain the phases. Emergency workers manage traffic. Shopkeepers, farmers, teachers, travellers, and children become part of the same temporary structure. The celestial event creates practical challenges on the ground. Food, transport, information, and safe viewing require human organisation. The shadow is natural, but the shared experience is partly built through care. Weather deepens this sense of dependence. A clear sky cannot be commanded, and clouds can turn strangers into a community of anxious observers. People exchange forecasts, point toward openings, and share rumours of clearer roads. A group may relocate together toward a patch of blue. When a cloud moves away from the sun in the final minutes, relief spreads through the crowd. When clouds remain, disappointment is also shared. The landscape may darken while the corona stays hidden, and people understand one another's loss without explanation. The event teaches that common hope does not guarantee success, but it can still bind people during uncertainty. Under a clear sky, the final approach transforms the crowd before totality begins. Casual conversation stops. Eclipse viewers lift in near unison. Every person follows the narrowing crescent, then lowers the filter only when the bright solar surface has fully disappeared. The timing matters for safety, yet it also produces a striking image of collective attention. Thousands of separate movements synchronize around the motion of the moon. No conductor directs them. The sky sets the rhythm. During totality, the crowd may become almost invisible to itself. Faces and clothing fade in the dim light, and the black sun dominates awareness. Still, the presence of others changes the emotional scale. Awe can feel safer when shared. The sudden darkness may carry an ancient unease, but voices nearby confirm that the event is being witnessed together. Wonder spreads through reaction. One person's cry can release another's emotion. Silence can deepen because it is communal. Tears may come not only from the sight above, but from the awareness of being part of a human gathering temporarily freed from ordinary distraction. The eclipse shows a crowd behaving as a single attentive organism while preserving every individual within it. Historical eclipses gather communities under different levels of understanding in earlier eras. The sudden loss of the sun may bring fear, ritual, or political meaning. Modern prediction changes that context. The path is known, the timing is calculated, and the return of sunlight is expected. Yet prediction also allows larger gatherings than chance alone would produce. People can travel deliberately into the shadow. Science does not reduce the communal power of the event, it makes the meeting possible. Astronomical knowledge tells people where to stand, while the eclipse reminds them that knowledge and emotion can occupy the same moment. A crowd can understand the mechanics and still be overwhelmed by the result. Public experiences of science are often indirect, encountered through images, classrooms, and screens. Totality places scientific knowledge into a shared physical event. Orbital inclination becomes the reason the eclipse is rare. Apparent size becomes the reason the moon covers the sun. Atmospheric scattering becomes the reason the horizon glows. Magnetic fields become visible through the corona. These ideas no longer belong only to explanation. They are present above a crowd that can see their consequences together. The result can create a form of scientific belonging. Astronomy is not something performed only by distant experts. It becomes a structure in which every witness is physically included. Earth, moon, and sun form the alignment, and the observers stand on one of those bodies inside the shadow of another. The community is not outside the phenomenon. It occupies a necessary position within it. When the first point of sunlight returns, the crowd often erupts again. The corona vanishes, the landscape brightens, and faces reappear. People look at one another after looking almost entirely upward. This return can feel like waking in company. Strangers exchange smiles, descriptions, and disbelief. Some compare what they noticed. Others remain quiet. The event has ended, but a shared memory has begun. Those present may never meet again, yet each becomes part of the other's recollection. The beach, street, rooftop, or field is remembered not as an empty location, but as a place filled with people who entered darkness together. This may be the strongest social lesson of totality. Connection does not always require a long relationship. It can arise from synchronized attention to something larger than the self. The eclipse lasts only minutes, but during those minutes, a crowd can become a community without needing a leader, a slogan, or a common identity. The only requirement is presence beneath the same moving shadow. When daylight returns, everyone leaves with a private version of the event, yet those versions remain linked by the knowledge that the wonder was not faced alone. A total solar eclipse lasts only a few minutes, yet memory does not measure it by the clock. The event enters experience with such intensity that its duration becomes almost irrelevant. Years later, the sequence may remain clear, from the thinning crescent to the sudden return of day. Ordinary afternoons disappear into one another, but totality often remains distinct. It becomes a fixed point in a life, a moment before which the world is known one way and after which it is known another. This is not because the eclipse reveals a hidden purpose or delivers a supernatural message. Its power comes from a simpler fact. It briefly places human existence beside scales of time, distance, and motion that exceed any individual life, then allows that contrast to become visible, rather than merely understood. The sun has burned for billions of years. The moon has crossed Earth's sky through ages without witnesses. The alignment continues according to motions that began long before any family, city, language, or memory. A person stands beneath the shadow for less than the length of a short conversation. Yet the scene carries the weight of deep time. That imbalance between duration and meaning can change how other moments are understood. Long experience is not always the same as deep experience. A weekend can redirect a life. A single conversation can alter a decision. A glance, a loss, a meeting, or a few minutes under an eclipsed sun can become more influential than years that seemed more substantial while they were happening. The eclipse makes this truth difficult to ignore because its brevity is built into the event. Totality cannot be paused. The moon continues moving. The corona appears and begins disappearing almost at once. Every second is visibly temporary. The awareness of ending is present from the beginning, and this gives the moment a concentration rarely found in ordinary time. Mortality enters the experience quietly. The shadow does not threaten life. Yet it reminds the observer that life is limited. A total eclipse may return to the same place only after centuries. The next similar alignment may cross a different continent, ocean, or generation. The sky follows cycles far longer than a human lifespan, and the individual has only a small number of chances to stand inside them. This knowledge can feel sad, but it can also feel clarifying. The event does not diminish life by placing it against cosmic scale. It intensifies life by showing how rare conscious presence is within that scale. The alignment happens whether anyone watches or not, but when a witness is present, the ancient motions become experience. Matter shaped inside stars has become capable of looking back at a star hidden by a moon. The human interval is brief, yet within it the universe is perceived, remembered, and given meaning. Grief often returns through this perspective. Those who have lost parents, partners, friends, or children may carry the eclipse into memory beside those absences. The darkened sun can resemble loss in its suddenness. Something central disappears. The familiar world becomes strange, and then ordinary life resumes even though the observer has changed. Daylight returns after totality, but it does not erase the darkness that has just occurred. In the same way, Routine returns after bereavement. Yet the lost person remains present through memory, habit, and the shape of what is missing. The eclipse does not solve grief or explain death. Its comfort, when comfort comes, lies in scale and belonging. An individual life may be temporary, but it unfolds within a universe of continuous transformation. Nothing in nature remains fixed. Stars form and exhaust their fuel. Planets cool. Continents move. Species appear and vanish. The moon slowly changes its distance from Earth. Human bodies also arise from matter, change through time, and return to the larger material world. The eclipse gathers these truths into a scene that is not cold or abstract. It is beautiful. This matters because mortality is often understood through fear of disappearance. Totality presents disappearance followed by revelation. The visible sun vanishes, yet the corona appears. The planets emerge. The horizon glows. What seems like absence becomes a different form of presence. The comparison must remain careful. Human death is not a temporary eclipse, and loss is not reversed by the return of daylight. Still, the event can offer a language of feeling without making a false promise. It shows that when one familiar form is removed, reality does not become empty. Other structures become visible. The world remains larger than the loss, and the lost life remains part of the history that shaped those who continue. This realization can make cosmic smallness feel less like erasure and more like inclusion. A person does not need to be permanent to belong. The observer beneath totality occupies one point in a chain of matter and time extending far beyond personal memory. The elements in the body come from ancient stars and planetary processes. The breath depends on a living earth shaped by oceans, rocks, microbes, plants, and countless generations of life. The mind watching the eclipse is the result of that entire history. Smallness does not mean separation from the universe. It means being contained within something larger. The emotional force of totality often survives because memory repeatedly returns to this sense of inclusion. In difficult years, the black sun may reappear in thought as evidence that reality once expanded beyond immediate pain. The memory does not remove suffering, but it provides another scale in which suffering can be held. A life can contain grief and still contain the corona. It can contain mortality and still contain wonder. These are not opposites. The ability to feel loss deeply comes from the same attachment that makes beauty matter. The eclipse joins them because it is both magnificent and vanishing. Its beauty cannot be separated from the knowledge that it will end. If totality remained for hours, it might become less intense. If it could be summoned at will, it might lose its authority. Its scarcity protects attention. The observer knows that the moment is passing, and therefore receives it with unusual openness. This pattern extends beyond eclipses. Many of the most important experiences are powerful because they cannot be held. Childhood ends, a conversation closes, a landscape changes, a loved voice is heard for the final time without being recognized as final. Human life is filled with events whose significance becomes clear only after they are gone. Totality differs because its ending is known in advance. The observer is allowed to understand the value of the moment while still inside it, for a few minutes. Attention and impermanence meet without disguise. That meeting can become a lesson carried into ordinary life. It can encourage greater care for brief connections, not because every moment is equally profound, but because duration offers no reliable measure of consequence. A short act of kindness may remain in memory for years. A few words may change the direction of another person's life. An afternoon in nature may become a source of strength long after the place is left behind. The eclipse demonstrates this principle with almost mathematical clarity. Its duration can be counted in minutes, yet its effect may continue across decades. The shadow passes, but the meaning does not move at the same speed. This is also why people feel an urge to tell others about totality. The story becomes a form of inheritance. One person receives advice from another, travels into the shadow, and later passes the recommendation onward. The experience cannot be transferred directly, but the possibility can. A memory becomes guidance. A brief alignment creates decisions that shape future journeys, friendships, and family stories. Children brought to an eclipse may later remember the adults who stood beside them. Friends may mark their lives by the places where they saw the corona. A person grieving someone absent may carry that person into the event through memory. Totality becomes connected to relationships that extend beyond the sky. Long after photographs fade and details blur, the emotional structure may remain. The world darkens, the hidden light appears, and the observer feels small without feeling alone. This may be the most enduring transformation. The eclipse does not prove that life has a cosmic purpose, and it doesn't remove uncertainty about death. It offers something quieter. It reveals that a temporary existence can still participate fully in grandeur. A moment does not need to last in order to be complete. A life does not need to be endless in order to belong to the universe. The moon's shadow crosses the ground and leaves no permanent mark on the landscape. Yet it marks memory. The corona shines for minutes and disappears into daylight. Yet its image remains inwardly visible. The observer returns to ordinary time carrying a different measure of value, one in which the shortest experiences may cast the longest shadows. A total solar eclipse deserves a place among life's essential experiences because it joins several forms of understanding that are usually kept apart. It is astronomy made visible, weather made personal, time made brief, and scale made immediate. The event can be explained through orbital motion, apparent size, atmospheric scattering, magnetic fields, and the geometry of shadow. None of these explanations weakens the experience. Together they reveal why the experience is possible and why it remains so rare. The moon crosses the sun because its orbit carries it into the correct line. The sun and moon appear nearly equal in size because distance balances difference in scale. The corona appears because the bright solar surface is hidden. The horizon glows because daylight continues beyond the edge of the central shadow. The planets emerge because the atmosphere above the observer darkens. Every element follows known physical law. Yet the combined result exceeds the emotional force of any diagram. Totality is one of the clearest examples of science deepening wonder rather than replacing it. The case for seeing one therefore begins with knowledge, but it does not end there. A total eclipse shows the solar system as a working structure rather than a collection of facts. The moon becomes a world moving through space. Earth becomes a rotating planet under a travelling shadow. The sun becomes a star with a visible outer atmosphere. The planets become neighbouring bodies sharing the same light. For a few minutes, the relationships between these objects are no longer hidden behind daylight or reduced to symbols on a page. They appear overhead and around the horizon. The observer stands inside the geometry, not outside it. This directness matters because many truths remain emotionally distant, even when they are intellectually understood. Earth's motion is known, but the ground feels still. The sun's vastness is known, but it looks small. The moon's distance is known, but it seems attached to the sky. Totality interrupts those ordinary impressions and replaces them with a view in which distance, motion, and alignment become impossible to ignore. The event also deserves pursuit because it reveals the fragility of opportunity. The path of totality is narrow, the duration is short, clouds may intervene, travel may fail. A person can live beneath the sun for decades and never stand where the moon covers it completely. The rarity gives the experience urgency without requiring fear. It encourages deliberate attention to something that cannot be summoned later at convenience. Modern life often creates the impression that almost any image or event can be replayed, streamed, photographed, or postponed. Totality resists that habit. A recording can preserve the appearance of the eclipsed sun, but it cannot reproduce the falling temperature, the circular twilight, the altered colours, the crowd's reaction, or the awareness that the moment is vanishing while it occurs. Presence is not a decorative part of the event. It is the event's central condition. This is another reason totality matters. It asks for full attention in a world designed to divide attention. The final minutes gather sight, hearing, touch, memory, and expectation into one narrow interval. The sky changes too quickly for boredom and too completely for distraction. The observer may prepare with equipment, maps, forecasts, and knowledge, but when the last sunlight disappears, preparation gives way to perception. The black disk, corona, planets, horizon, temperature, and sound arrive together. The mind has no need to search for significance because significance is already present in the scale of the scene. Such concentration can be restorative. It does not remove difficulty from life, but it briefly weakens the constant pressure of private concerns. The self becomes smaller, and the surrounding universe becomes larger. Smallness in this setting is not defeat. It is relief from the burden of being the centre of every thought. Totality also offers a rare form of collective experience. Crowds gather for many reasons, but few gatherings are organised by an event that belongs to no institution, nation, belief, or owner. The moon's shadow crosses borders without permission. It darkens farms, cities, oceans, and mountains according to geometry alone. People arrive from different places and stand together beneath a condition none can control. When the sun disappears, reaction becomes shared. Cheers rise, silence follows, and strangers become connected by attention. The eclipse does not erase division permanently, and it should not be burdened with claims it cannot fulfill. Yet it demonstrates that common awe is possible. It shows that people can look toward the same reality and feel, for a brief interval, that belonging extends beyond familiar groups. The experience therefore carries human value as well as scientific value. It becomes a memory linked to companions, family, strangers, and place. Years later, the eclipse is remembered not only as a celestial event, but as the day people gathered, waited, worried about clouds, and entered darkness together. The case for seeing totality also rests on its relationship with mortality. Human life is short beside celestial cycles, and each person receives only a limited number of chances to meet the shadow. This fact can sound severe, but the eclipse transforms it into something gentler. The event shows that brevity does not reduce meaning. Totality may last less than a few minutes and still influence decades. The corona disappears, yet its image remains. The shadow leaves no mark on the ground, yet it marks memory. A temporary experience can become permanent in consequence. This pattern reflects life itself. Conversations, journeys, acts of care, encounters with nature, and moments beside loved ones often gain importance far beyond their length. The eclipse offers a clear demonstration that value cannot be measured only by duration. It arrives, changes the world, and leaves, while the observer continues differently. For those carrying grief, The event may offer a quiet form of perspective. It does not solve loss or promise reunion. It does not convert astronomy into religion. It simply places personal sorrow within a larger reality that continues to contain beauty, structure, and transformation. The sun vanishes from sight, and hidden light appears around it. Day returns, but the memory of darkness remains. The natural comparison is imperfect, yet emotionally useful. Absence and presence can exist together. A life can contain grief and still receive wonder. A person can feel temporary and still feel connected to something vast. Totality makes this connection visible without demanding a particular belief. It is enough that the same matter forming human bodies belongs to the universe that forms stars, planets, and moons. The observer beneath the eclipse is not separate from the scene. The observer stands on one of its worlds and watches another world cross a star. Practical objections remain. Travel can be difficult. Weather can disappoint. Costs and access are unequal. Not every person can cross a continent or wait for a distant eclipse. Yet the recommendation remains powerful because the experience is worth treating as a genuine life priority when circumstances allow. It belongs beside other encounters with nature that widen perspective, but it has no close substitute. Mountains reveal scale, oceans reveal distance, and dark skies reveal the stars. Totality combines scale, distance, darkness, motion, rarity, and transformation in one event. It does not require athletic ability, specialized education, or spiritual commitment. It requires safe viewing, careful planning, and presence within the path. The reward is not ownership of an object, but participation in a temporary alignment. Its importance also lies in the way it changes future attention. After totality, an ordinary sunrise, a clear afternoon, or a thin crescent moon can carry new depth. The sky is no longer merely background. It becomes evidence of motion, distance, and hidden structure, remembered through one brief interval when those truths became visible at once. The final case for seeing a total solar eclipse is therefore simple. It reveals hidden parts of the sun, visible structure in the solar system, and hidden capacities within human attention. It shows how ordinary daylight depends on a star, how a nearby moon can transform a planet's surface, and how strangers can become a community beneath one shadow. It makes time feel both brief and immense. It reduces the self without reducing human worth. It joins fact with feeling and mortality with wonder. When the first sunlight returns, the sky becomes familiar again, but familiarity no longer feels complete. The observer has seen what daylight hides and what a few minutes can contain. The eclipse ends, yet its deepest effect begins afterward, in the years shaped by the memory of standing beneath a black sun and discovering that a short passage through darkness can leave a lasting form of light.